Welcome to Maths and Science by IITIAN. Till now, more than 100 videos are released on the concepts of mathematics. JEE, for JEE, CBSE, CSIR and Maths Olympiad. In this, a good example of power tower of a matrix. People usually might have heard about power tower of an integer, power tower of a real number, power tower of a complex number. Power tower of a matrix we are going to discuss today. This is power tower of a matrix. Let A be a matrix. We have to find out what will be the value of a to the power of a to the power of a up to infinity. This is the power tower of a matrix. It is a very difficult problem, and I have already given some amount of introduction in the last class when we found a to the power of a. A is a matrix, matrix to the power of matrix. Here matrix to the power of matrix to the power of matrix to the power of up to infinity. What is its value? We are going to find out. And I have given an introduction of e to the power of a, where e is equal to ln natural logarithm base, that is 2.78. Now, e to the power of a concept is already there. Please see that video for better understanding. Then a to the power of a concept is also developed in the last class. Please see that video also for better understanding. Now we are going to develop a concept to find a to the power of a to the power of a to the power of a up to infinity is how much, when a is a matrix. Under what conditions we can define this? Because the conditions of definition, understanding the concepts is more relevant for higher competitive examinations like JEE Advanced, GATE, CSIR and Maths Olympiad, rather than doing the problems. Problems can be done. A small error in the problems also can be rectified if you know the concepts well. Let us go for the concepts. Instead of delving into the problem and problem solution, this channel is made for clearing the concepts. Now, let us delve into the solution. What is the question? A to the power of a to the power of a up to infinity is how much if a is a matrix? Solution: to represent the power tower of a matrix, in simplified form, x is equal to, let us say x is equal to a to the power of x. A to the power of a to the power of a, let x is equal to a to the power of a to the power of a up to infinity, then x is equal to a to the power of x. Then this x is equal to a to the power of x, if you can solve x from this equation, you are done for solving the given problem. Now, for a to the power of a, For a to the power of a in the last class, what we have developed? A should be diagonalizable. Diagonalizable. That means A should be represented in this form, P D into P inverse. That is what I have explained in the last class. Please refer to the last class where D is the diagonal matrix, and P inverse also I have defined. When A can be represented in this form, then it is diagonalizable. A will be diagonalizable. The first and foremost condition, it should be diagonalizable. For fulfilling this, what to do? I have explained in the previous class, and here x is equal to a to the power of x. Let us replace the value of a as PDP inverse. PDP inverse to the power of x. Can we write like this? The given problem, if we can find the solution for PDP inverse to the power of x, then we got the value of x. Please recollect my previous videos where power tower of a scalar I have given. Let us bring that concept also into this. Second step, to have scalar analogy. Scalar power tower. Let P be some scalar. Let x is equal to P to the power of x. This type of problems, many problems we have solved in the previous classes. Please see those scalar power towers lectures and understand. Here, what is the value of P? Implies P belongs to the set e to the power of, this we have done already. Minus e to the power of 1 by e, that is approximately, it belongs to 0.0659. Please recollect this. Please recollect. Now, if we assume or if we connect the scalar power tower to the matrix power tower, then let A is equal to, let us connect both of them. Let us assume, don't worry, we don't know what is A. Let A is equal to some scalar into diagonal matrix, unit matrix, because the matrix should be diagonalizable. That means the matrix whatever A is given, it should be represented in a diagonal form, and let that be some scalar into unit matrix. Unit matrix is a diagonal matrix. Then it implies x is equal to a to the power of x is equal to a to the power of x into I to the power of x. What is I to the power of 1, I to the power of 2, I to the power of 3? Everything is I only. That means a to the power of x into I. Can we write like that? We are slowly proceeding towards a simplified form to get a solution. Can we write like this? A is equal to ai, x is equal to here let us use capital X, let us not use small x, because everywhere we are using the capital X. Left hand side is capital X. Can we write like this? Which implies each element of x is equal to, please understand this, these concepts only important, is such that x is equal to a to the power of x because of this. Which implies x is equal to x into I, provided everything whatever I am writing here, it is not applicable for all the matrices, it is only applicable for the diagonalizable matrix. Which implies x is equal to a to the power of x, that implies a belongs to set e to the power of minus e closed interval e to the power of 1 by e, which we have proved in the previous lectures. Now we have come to a conclusion that A is a diagonalizable matrix, hence some scalar into I is A. That is the important conclusion we made here. And let us take A is equal to something like any scalar we can take in between e to the power of minus e and e to the power of 1 by e. What is e to the power of minus e? That is 0.0657659 and 1.446. What is the value in between them? We can take between e to the power of minus e and e to the power of 1 by e. Any value you please suggest between 0.0659 and 1.446. Can we take e to the power of minus 1 so that it will be at least let A is equal to e to the power of minus 1. I am taking an example. Let A is equal to e to the power of minus 1 for clarity. Then x is equal to a to the power of x is equal to e to the power of minus 1 to the power of x is equal to e to the power of minus x. By taking logarithm on both sides, ln x is equal to minus x into ln e to the base e. That is equal to minus x. That implies x is equal to minus ln x. X plus ln x is equal to 0. X plus ln x is equal to 0. If x is positive, then if x is equal to positive, then ln x should be negative. For ln x to be negative, x should be less than 1. Let us try with let x is equal to 0.5. Then 0.5 plus ln 0.5 is equal to, what is the value of ln 0.5? ln 1 by 2. 1 by 2 is ln 1 minus ln 2. ln 2 is 0.693, we know it. .5 plus ln 1 minus ln 2. ln 1 is 0 minus 0.693, that is equal to minus 0.193. That means it is above 0.5. If x is equal to 1, at x is equal to 0.6, 0.6 plus ln 0.6. What is ln 0.6? ln 1 divided by 0.67, let us say 2 by 3, 0.6 also we can say 0.2 into 3. Those values how to find out for 6, 0.6 and all those things I have explained you. It is 0.6 minus 0.5108. This is plus 0.51, 0.6 is plus 0.09. Let us take out last two digits. Let us not worry much. We are only approximately finding. That means x value lies between, because the value x plus ln x is changing the sign here. Hence, x lies between 0.5 and 0.6. Let us say x is equal to 0.55 or 0.56. Let us see. This is the answer. If online calculator is given in the examination, you can directly solve. If online calculator is not given, go by this and you can solve the equation. Then x is equal to x into I. Then our final solution is if A is equal to, it is an example for a numerical for you to understand. A is equal to e to the power of minus 1 into n into I, that is e to the power of minus 1, 0, 0, e to the power of minus 1. Then a to the power of a to the power of a up to infinity is equal to x implies x is equal to x into I. Small x into I. That implies x is equal to, what is x value here? 0.56, let us say 0.56 into I is 1001. This is the answer. I think you understood the procedure and you got the answer, and provided the element A is diagonalizable, we cannot apply this rule to all the matrix. Matrix A is diagonalizable, not element, sorry, it says it's a matrix. A should be diagonalizable, and for diagonalizability of the matrix, we have seen A is equal to P D P inverse. Then we can find the value of this particular power tower of a matrix. A is diagonalizable or scalar multiple of identity. provided 1 A is diagonalizable or A is scalar multiple of I. You just see here. Scalar multiple of I. Then it is scalar multiple of I. A is equal to e to the power of minus 1 into I. That is what we have taken. You can take A is equal to, for example, you can even go for this. A is equal to 1 by square root of E into I, and take it as a homework and check what will be A to the power of A to the power of A up to infinity is equal to how much? These are all the ways we can define a power tower of a matrix, and if any problem has come to you, either like a power tower or any problem, please don't get unfamiliar with whatever you have seen in the examination, because these concepts are clear to you only for bringing familiarity to different types of matrices, different types of unfamiliar matrix operations, so that you get familiar with the concepts and you can apply them without any problem in the examination and do better. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture. Thank you for listening to me. Best of luck. Thank you. And if there is a value addition because of this lecture to you, please share the video and all my videos on this channel and subscribe to my channel Maths and Science by IITIAN. Please look into the problems on a holistic view, and if there are any small errors of writing, please correct them, and these are the basic concepts. Please clear on the concepts rather than on the numerals. Best of luck. Thank you.